Hello everyone. So yesterday from our first HBL lesson, we have learned about the two types of separation techniques that is used to separate matter. Now, why do we want to separate matter? We separate matter for a variety of reasons. Okay, the first reason is because we want to obtain useful substances. Let's say, for an example, in the salvaging of iron and steel from your junkyards, okay, or your dumps. The next thing is we also want to determine if substances are pure. So yesterday we learned two types of separation techniques. One of them is magnetic attraction, making use of the property that some substances are magnetic and some substances are non-magnetic. Next thing will be filtration, okay, making use of the physical properties that some of them are insoluble, okay, in a liquid. And so it's very easy to separate this insoluble solid by filtering. And if we want to do filtration, we need to have a filter funnel and we also need to have a filter paper together with a beaker. Okay, and we learn quite some number of keywords, right? We say that the insoluble solid that is left behind in the filter paper, this is known as your good residue, and the liquid that actually is able to pass through the filter paper and be collected in the beaker, this is known as your filtrate. Okay, now today we are going to be looking at how filtration can be modified if we are looking at a different scenario. Okay, so let's look at your next page of your notes on page 7. There is a question here that says, how do you separate a soluble solid from an insoluble solid? For example, we talk about salt and sand. Okay, so let's say we talk about salt and we talk about sand over here. Okay, salt and sand. Now you know that sand is insoluble in water. Okay, but salt can dissolve in water. So we're talking about two solids here that can be separated. They still can be separated. I don't think you want to actually go through the solid sand and salt mixture one by one and try and pull out all the sand particles from the salt particles, right? Because that is simply too tedious. So what you're going to do is, if you want to separate sand and salt, you will have to choose a solvent very carefully. Now you remember in chapter 3, we say solvent is basically what the solute dissolves in. So over here, you can choose water to be the solvent. Okay, over here you can choose water to be the solvent. And if water is the solvent, which one do you think will be able to dissolve in water? Will it be salt or will it be sand? Yes, so for those of you who are able to tell me that it is salt that can dissolve in sand, you're absolutely right. So what do you think will happen if you were to do this? So you will have to fill in your answer here, right? So maybe we observe an animation first before you actually fill in your answer. So you can see you will crush the two mixtures together of salt and sand, and then you will pour this into water. Now, what are you trying to do here? You are trying to dissolve all the salt. So whatever that's left behind is sand. Then what is this method? You give a filter paper and a filter funnel and a beaker. Yes, you're right. This is actually filtration. So you are doing two steps here. Okay, so let's look again at the animation. Alright, so what do you do if you have an insoluble solid and a soluble solid? You will crush the mixtures together, then you will dissolve the soluble solid, which in this case is your salt, in water, leaving your sand behind. Then you will carry out the physical separation of filtration. Okay, the salt solution is small enough to pass through the membrane and can be collected in the beaker. And then what is left behind in the filter paper is your insoluble solid. Okay, so if you look very carefully here, what is left behind here in the filter paper is your insoluble solid, which in this case is your sand. And this is known as your residue. Okay, now your salt in the water has already been successfully dissolved. So this salt solution, okay, so the salt You may want to write this down. Follow Miss Lee. This salt solution is known as your filtrate. And this can be collected in the beaker. Alright, so what do you think is the method here? What did we first do? Correct. What we first did was we dissolved it. So basically, if you want to separate a soluble solid, in this case your salt, from your sand, you will first have to dissolve the salt to get salt solution. Then what is this method? What is this separation technique known as? Good, some of you all guessed it correctly from the first letter. Is known as filtration. So some solvents that we commonly use will be water, or we can also use ethanol, which is a type of alcohol. Okay, now why do we do this method? Because we want to choose a solvent in which one of the solid is soluble and the other solid is insoluble. Now when one of the solid is soluble, it can dissolve in water. What is left behind is the insoluble solid. Therefore, you can filter it using filtration. Okay, so if you look at the method over here, all right, we say that sand does not dissolve in water. It is insoluble. What was the method that we did here? We actually dissolve your salt solution, your salt in water to get salt solution. Then after that, when we separated sand from the salt solution by using filtration. And what did we get? We got your residue, which is your sand that is left behind. And the salt that is in solution already, because it's dissolved, is small enough to pass through the pores of your membrane, and therefore it will collect here and form your filtrate. Okay? So this is a scenario that you might get in the exam. So you may want to put a star here. This is quite important. All right. So if we use sodium chloride solution plus sand, we will first have to filter the mixture. Okay, so what is in your filtrate? Your filtrate is your sodium chloride solution. Now, you may want to write this down. Sodium chloride, okay, actually just means salt. Alright, and the chemical formula for sodium chloride is NaCl. Na is sodium, chloride, okay, your chloride is Cl. So your sodium chloride is a soluble solute. It's a soluble solid, okay, otherwise known as your solute. And your sand here is known as your insoluble solid. Okay? All right. So once, let's say, if in your filtrate, okay, you are left with your sodium chloride solution already, right? You might ask me, Miss Lee, so now let's say I can get the sand already, no problem. Now I want to get the salt back in solid form because now it's liquid, right? So I want to get the salt. I want to make sure that I get salt. I don't want salt in solution. I want the pure salt crystals. Then what do? We will have to use the process of evaporation. Okay, then once we are able to use evaporation, so we put the salt solution in an evaporating dish over a wire gauze, over a tripod stand, and a Bunsen burner, and then we are able to evaporate the water into water vapor. What will be left behind will be your crystals of sodium chloride. That is how you are able to get the solid sodium chloride back. Because over here, your sodium chloride or your salt is already dissolved in water. You don't get the salt crystals anymore. It's in the liquid form here. Okay? If you need some time to understand this, you may pause the video. Okay, so let's continue. After you filter the mixture of salt solution and water, can you tell me what is the residue? Good. Some of you are able to identify that the residue is actually your sand. Okay, sand, majority of it is sand, and some traces of sodium chloride solution. Okay, some traces of sodium chloride solution. Some of the sodium chloride solution may be left behind or present inside, in between the sand particles. So we will wash this with distilled water. Why do we want to wash it with distilled water, you may ask? Okay. Something that is good for you to take note is, why do we wash this with distilled water? Because the distilled water is able to, you may want to write this down please, dissolve the traces of sodium chloride solution because sodium chloride is soluble in water. So whatever sodium chloride that is inside the residue here, okay, whatever sodium chloride that may be stuck inside the residue here because there are spaces in between the sand particles, okay, you need to get rid of it so that it can come out as a filtrate. You will wash it together with distilled water because distilled water will dissolve the sodium chloride. So what is really left behind in the filter paper, you may write this, okay, left behind in your filter paper is really your sand, which is your insoluble solid. Okay? All right, so now let's move on. All right, now we're going to go to page 8. So we have learned two types of separation techniques already. First of which was magnetic attraction. The second was filtration, when you want to get an insoluble solid from a liquid. Okay, or you can even use filtration when you have two solids that are mixed together. However, one has to be soluble and the other one has to be insoluble. But what is important is you must choose the right solvent. Okay, so take for the example that we saw earlier, which we use sand and salt. And then we use water, distilled water, because distilled water is able to dissolve your salt. Therefore, your sand will be left behind and your salt will be in the solution. And if you want to get salt, then you will have to evaporate to dryness to get your solid salt crystals back. Now, the third method that we're going to be discussing today in great detail will be the technique of evaporation. So I'm very sure in primary school you know what is evaporation, right? Your primary school science teacher would have said that if there's a puddle of water, okay, in your school parade square, after a while, after half an hour or 45 minutes, when you come back, you realize that the puddle of water is getting smaller and smaller, getting lesser and lesser. And that's because water in the puddle is actually evaporating to form water vapor into the atmosphere. So why is evaporation also considered a separation technique? How can evaporation be used to separate mixtures? Okay, so first of all, let's look at the definition of evaporation. We basically use evaporation to separate dissolved solids from a solid and liquid mixture. Okay, you may want to pause the video here to copy down the blanks in your notes. All right, so we use evaporation to separate solids that are already dissolved. This is quite important. So you may want to highlight this in your notes. All right. So we want to separate solids that are already dissolved from a solid and a liquid mixture. What do I mean by that? So can you recall the earlier example on page 7 when we talk about your sodium chloride solution? Okay, you talk about your sodium chloride solution and sand. So after we filter this, we are left in your filtrate, your salt solution, right? So your salt is actually a dissolved solid in water. So now if I want to get the salt crystal, so if I want to separate this solid from the solution, I want to separate the salt from the water, I will have to use evaporation. And from the term itself, evaporation, you know, you will have to use what is this apparatus here, which we learned in chapter 1? Good. Some of you all know how to draw it as well. We will have to use an evaporating dish. So we will use an evaporating dish on top of your wire gauze, and then we will put the wire gauze on top of your tripod stand, and we will use a Bunsen burner. All right. So this is your salt solution. So the water vapor, the water will then evaporate to form water vapor, leaving behind all your salt crystals. Now, that is how you are able to separate. You are able to separate the salt from the solid liquid mixture because salt was originally dissolved. Okay, so if you understand the definition, now we must talk about why is evaporation, why can we use evaporation, or more like in which two situations do we use evaporation? Can we use evaporation all the time? Not all the time to separate mixtures. So therefore, evaporation makes use of two facts. Okay, the principle of evaporation is very important. So you may want to put a star here. These two things are quite important. You will also need to be able to know how to draw this setup. So can you please put two stars here as well. And when you draw, don't draw the 3D shape like this. You have to draw a two-dimensional figure like that. Okay, so now let's move on. So what are the two things that evaporation, or two facts that evaporation actually makes use of? So we use evaporation only when the solvent, that means the liquid in the solution, can vaporize. Now, if you look at the word vaporize, it comes from the word vapor. That means this solution can become vapor from liquid at any temperature. That means it can become vapor at room temperature. It can also become vapor at hotter temperatures. So the first scenario where we can apply evaporation is if and only if the solvent in the solution can become a vapor. If the solvent in the solution cannot become a vapor at any temperature, then evaporation will not be very useful. Okay, the second scenario, that is the second situation that must be present in order for evaporation to take place, is if the solute, so we talk about the solvent already, right? Now we talk about the solute. If the solute that was dissolved in the solvent can be, good, some of y'all can guess the two words, can be left behind and become the, now when the solid becomes left behind and remains behind, we call it the residue. Okay, now this process is called evaporation to dryness. Now we saw this earlier with our sodium chloride and sodium chloride solution and sand, right, mixture. So basically, evaporation makes use of two facts. You may want to take note of this, okay? So the first fact is that the solvent can become a vapor at any temperature. So you may want to highlight these two words. Solvent can become vapor at any temperature. The next scenario is that the solute, okay, is that this solute that is dissolved in the solvent must be left behind and become a residue. So there are two scenarios, or the evaporation makes use of the two facts. So when evaporation is used as a separation technique, okay, it is actually using two particular concepts. The first concept is that the solvent can become vapor. That is why the solvent will, in quote and inverted commas, we don't use this, okay, but in lack for a better term, this solvent can disappear. And why does it disappear from the mixture? It's or from the mixture, is because it has become vapor. That's why it's not there anymore. And number two is that what should be left behind should have been the original solid that was soluble in that solvent. Okay, so that's why it makes use of these two facts. And this process to get the solid to be left behind is known as evaporation to dryness. Please highlight this process here. Okay, so now let's move on. How does the process of evaporation actually take place? All right, how does it actually take place? Oops, sorry for this technical difficulty. All right, sorry for the technical difficulty. So let's get back to this process. We first must, if you look at this, would you say that the solution is being, what is being carried out to this sugar solution here? Now, when we use sugar, sugar is the dissolved solid inside the water, inside the solvent, which is probably water. So what will happen is we first heat the solution. All right, we will first heat the solution over a water bath. So the water bath is here. Now, you may ask, Miss Lee, why don't we just heat it directly? Two reasons. Number one, maybe in this case, if you heat it too quickly, you know that sugar can actually caramelize, right? It can be cooked. So you may not want that scenario whereby the sugar becomes brown, because you want to leave behind the pure white sugar crystals. Okay, next thing is that when the mixture is completely evaporated, that means the solvent, okay, the water in this sugar solution has completely vaporized or has evaporated, you realize that no water is actually left behind. Okay, and the sugar crystals that is left behind is known as your residue. So can anybody tell me what is this process that we are talking about here? Yes, it's a process of evaporation, and we consider this the process of evaporation to complete dryness. Okay, we say evaporation to dryness. All right, so let's move on. Now I'd like to show you a simple animation so that it's a little bit easier for you to understand the process of evaporation. Okay, so as promised, let's have a look at this simple animation that shows you evaporation when there is direct heating. Now, evaporation can take place at any temperature. You don't necessarily have to use heating. Okay, but this animation shows you what happens in evaporation when you use heating. All right, so let's try and identify these two-dimensional apparatus here. Can you tell me what is this apparatus that we're looking at? Good, this is your evaporating dish. Then these crosses in a straight line actually represent your wire gauze, and this represents your tripod stand, and of course this is your Bunsen burner. So remember, evaporation is when you're trying to get a dissolved solid from a solid liquid mixture. Okay, so if you look carefully here, all right, we say that this setup will basically separate the soluble solid and liquid through direct heating. So you can see that this method is used when the soluble solid will not decompose over direct heating. So just now, some of you may be asking, why is it? Okay, some of you might actually be asking, why is it we did not put the evaporating dish with the sugar solution directly above the flame? Now, that's because sugar decomposes with direct heating. And since it decomposes with direct heating, it is not advisable to use sugar solution directly over the flame. And that's why we used a beaker with water to form a water bath. So let's start again. Okay, so what happens is that we will then put this salt solution, and then we will heat it directly. And in this experiment, we use salt, and you can see that water vapor starts to form because water is evaporating in the process of heating. And when we use evaporation to dryness, you can see that as more and more water becomes vapor, what is actually left behind will be your salt crystals, will be your solute. Okay, so let's watch this again, and this time Miss Lee will not say very much. Okay, so notice in this setup, we will use salt solution, not sugar, because sugar decomposes. You will notice that water will start to evaporate. This is the process of evaporation, which is your third separation technique. And then if we evaporate to dryness, you will notice that the solid, which was originally soluble, okay, the dissolved solid that is present, which is salt, will be left behind. Okay? All right, so just like magnetic attraction and filtration, there are also industrial applications of evaporation. And one of them is actually the production of salt from seawater. Okay, now how many of you love to eat salty food? I'm very sure a lot of you will raise your hands behind the computer screen and Miss Lee cannot see, but it's okay. Too much salt is not good for you, because salt, your doctors will tell you that salt will actually cause hypertension, which is a type of cardiovascular disorder. Okay, but actually salt is a very popular food ingredient all over the world. That's because it can be used as a preservative. So, and it's also used as seasoning in dishes. Okay, so one of the industrial or real world applications of evaporation is basically the production of salt from seawater. Okay, so basically, the summary of this process is in some parts of the world where the temperatures are very high, what they will do is they will allow the seawater from the ocean to flow into these salt pans. Now, these salt pans are like little squarish structures in the ground that allow the seawater to accumulate. And the purpose of this is that they want the sun in the atmosphere using heat, okay, to evaporate all the water in the seawater, leaving behind these stacks and piles of salt. So this is actually salt heaps, and this salt is then piled up to form heaps, okay, and then they will further dry this, and this is how they actually produce salt. Quite interesting, right? The method is so simple, but yet it is such a foolproof method to get something as successful in cooking as salt. Now, I think we should pause the video now to watch a little video of our own. So let's watch this video of how salt is actually made in Spain. So you can see that this is your seawater, your salt that is dissolved inside water to form your seawater here. Okay. So you can see that now you have your salt crystals. These are your salt pans. Okay, these are your salt pans. See, they are squarish in shape, allowing seawater to be, and these are your heaps of salt that has been piled up. See what the workers are doing? They are actually pushing in, scraping in all the salt, because the water in the seawater has evaporated. So these are your salt pans. You see how squarish they are? These are your salt pans. At the side here will be your heaps of salt. Okay? Look at the color of salt. So now they are collecting the salt, but it's still a little bit dirty, yeah? So it needs to be treated first and further dried to be safely eaten and packaged. Okay, so you saw basically how evaporation can be used in companies that make salt. Okay, so the third separation technique that we have covered today will be to separate a soluble solid from a liquid. Okay, separate a soluble solid from a liquid, and you can do this through the process of evaporation. Okay, and if we evaporate to dryness, so we use heat for evaporation, what we can do is that we can actually get the solid to be left behind to form the residue, so we can obtain a solid in the process when we use heat to evaporate. Okay, and this is basically used in the industrial application of salt production. All right, so in evaporation we can use heat. Now evaporation can take place in any temperature. Okay, you do not need to provide heat, but when we use heat for evaporation, we are able to get the solid to be left behind as a form of residue, because all the solvent has become vapor. And since the solvent has become vapor, basically your solid will then be left behind. All right? Okay, good. So today we have covered the third separation technique, which is known as evaporation, and we can see how the industrial application of evaporation is seen in salt production. Okay, now we're going to pause the lesson today, all right, because I'm now going to ask you to look at your three separation technique methods that we have covered so far: magnetic attraction, filtration, and evaporation. All right, we will be giving you an SLS lesson package to go through, and then tomorrow we will meet again to talk about the next or the fourth separation technique. Okay, and the fourth separation technique is also separating, can also be used to separate mixtures as well. Okay, so please proceed to your SLS now. Thank you.